Welcome, ladies and gentlemen, and those online, to our 29th annual exhibit of hydrogen and fuel cell technologies. We've been here since the mid-90s, discussing when things are going to be happening. We've always wondered, even if we create all this hydrogen we need in order to transition to a net zero economy, how are we going to distribute it? It's been a debated issue, and there's an expert who's going to be on the stage here to talk about transformation of the German gas infrastructure to hydrogen. Please welcome with me Björn Munko, who's the head of gas technologies and energy systems at DVGW.
Yes.
Hello, Björn.
Hi. Hi there.
So we love our short forms. Could you introduce us to DVGW, what you do and what it stands for?
Yes. DVGW is Deutsche Verein des Gas- und Wasserfachs, which is the German Technical and Scientific Association for Gas and Water. A little bit long. Our core business is the rules and regulations, and that what I do with my team, the rules and regulations for the German gas infrastructure. Then we do the rules and regulations for the German water infrastructure. And infrastructure is from production until usage, and we are mentioned in the German Energy Act as the setter of the rules for the infrastructure. And that is not only for gas, but in the meantime also for hydrogen. So we're doing all the rules and regulations for the German hydrogen infrastructure. Most of it, of course, pipeline-based infrastructure, but upstream to downstream. That is then based, obviously, we need a lot of knowledge on that. So we have some 14,000 members in the association, that is personal members, but also all the TSOs and DSOs, so the distribution companies and the large transport companies of gas. In Germany, it's a little bit special case that we have some 15 TSOs and 600 DSOs distributing the gas, and in the future then also the hydrogen in Germany. So that what we do is backed up by a lot of R&D. We have a budget of some 10 million per year of R&D, and with third-party funding, I think we're handling some 100 million euros per year of R&D activity. And in the last years, a lot of that in hydrogen. And then the last thing I want to mention is we also do a lot of vocational training. 30,000 people in our seminars and courses from our members, but also outside. And that goes from basic courses up to technical experts for operation and also for installation and building infrastructure.
Wow, that's a big field. Our subject today, of course, is the transformation of the German gas infrastructure to hydrogen. If I could begin with an analogy, I do the electrolysis elevator pitches. You have a pile of these people who produce hydrogen through electrolysis. It's green hydrogen optimally because it uses renewable energy. And the big question is, where do we go with this energy? Sometimes, literally, you produce hydrogen and there's no market right now. And the big debate we had was one company, ITM Power, was saying, we're going to put it into the gas grid. You have the guys from Linde who is saying, we shed tears when you burn hydrogen rather than using it in a fuel cell because it's not necessarily that efficient. But the next debate was, how much hydrogen can you put in this gas grid? Some people were saying, oh my goodness, 4% maximum. Other people were saying maybe 10, 15. ITM Power was optimistic, 25%, and they actually were doing this in a test phase. So, of course, in order to develop renewable energies, you have to stop shutting down the wind turbines. Any use of excess energy is a net benefit. But how much hydrogen can we indeed put into the German gas infrastructure?
Actually, we can put 100% of hydrogen into the gas infrastructure. Of course, we have to do some conversion. We have done a lot of field testing, and we have done a lot of testing of materials. So we have field tests where we have 20% blending. So when we talk about blending, we will probably talk about something about 20%, because the downstream applications for them, that's mostly the limit that we have. We have some special applications, of course, like mobility, where we have 2%, but there we could, for example, clean that up. But then we have analyzed the German gas grid and the materials used in the German gas grid, especially the steel materials. And except for some castings, all the materials that the pipelines are made of can be used for 100% hydrogen. So with very, compared to the value of the German gas infrastructure, with very little also commercial effort, we can convert the complete German gas infrastructure, and that is more than 600,000 kilometers of pipelines in the ground. We can convert that, either use it for blending or we can convert it to 100% hydrogen use.
This blows my mind because in the past we've always been discussing how we have to set up an entirely separate infrastructure for hydrogen. No one did the empirical testing. Did you actually have scientists looking at the issues and analyzing empirical data to see how much was possible? Who wrote the norm? Who did the study on this?
That was us with our members, and of course also within the European and the German community. So we're doing a lot of research also in the European community, but we also do a lot of our own research and a lot of also with other research institutes. So we have within the organizations we have a couple of institutes that belong to the DVGW, and we have a lot of institutes that we associate with the DVGW, where we do all the R&D research work. And we have done the empirical testing, and just last month we had our last report coming out, and that was especially the one that I mentioned on the steel materials used in the German pipelines, that basically proves that under the conditions we have in the pipelines, and you always talk about the fracture and the corrosion, but under the conditions we have in the pipelines, where we have usually very stable pressure and we do not have a lot of pressure fluctuation, that there we would have, if we would put 100% hydrogen in the pipelines, we have residual lifetimes of the grid of several decades.
Yeah, this is just phenomenal. Of course, what we can do, and physicists tell us what we can do, does not always mean it's possible to do legally or that other people in the industry understand this. So let's take the case scenario. Right now we're shutting down, we're curtailing renewable energy. Right now the electrolysis industry is happy to jump in and capture any wasted kilowatt hour. You could convert that into hydrogen. You said 20% mix in the grid is possible, maybe a little bit less for some applications, but generally speaking, because people use natural gas for their boilers, there's actually 2 flavors of natural gas and the burners are slightly different, but we can do the math on that. With these mixes and with the knowledge of what is possible, are you allowed to do that right now?
You were asking who is writing the norms, and we are doing that together with our members and all the technical experts. And this is thousands of technical experts we have there in the committees, and it's an open process where when we issue the draft of the standard, obviously can be commented by public. And at the moment, also when we talk about downstream applications like home heating, from the home heating appliance suppliers, we have basically the go-ahead to use those with 5%. 10% also possible if they are used in the standard conditions, so if they have the standard settings. In all the field testing we have done, we have one project in Schopsdorf, which is close to Berlin, where we have been running for 2 heating periods now. So winter of 21-22 and winter of 22-23. A company called Avacon, the operator there, they have been running 350 households on 20% for blending in the home heating appliances. And the specialty there is, in addition to the 20% hydrogen, they also have a lot of biomethane in the grid. So basically, there have been this village there for 2 winters now. It has been running almost climate neutral on the home heating, and I think that's a pretty that's a pretty good sign to the decarbonization and defossilizing the German gas applications in the German gas grid.
Whenever we talk about energy, at least here, we've had this really bad habit of talking about the electrical grid. We know the electrical grid doesn't store energy, it just passes it on. We know that hydrogen's only an energy carrier, but it's easily stored. But just for a point of reference here, in terms of size, what is larger, the energy that is carried by the electrical grid or the energy you can distribute with the gas infrastructure?
Certainly the energy that is distributed by the gas infrastructure. We are using some 3,500 terawatt hours of energy in Germany. 20% of that is electricity. And if we talk about our electricity, 50% is renewable now. So we are at 10% renewables electricity in the overall energy consumption in Germany. When we add some renewable molecules that we have in the system, we are in total at about 16% renewables. So there's no question we want to go out of coal, we want to go out of oil, we have just left nuclear, so we need to defossilize the molecule system, and we are able to defossilize the molecule system with the German gas grid.
So I noticed that you, coal, oil, nuclear, you didn't mention natural gas, which is kind of expensive right now because it's been weaponized and shut off from Russia. When we talk about the gas grid, what you're talking about here is actually replacing the hydrocarbon sources that we've been importing through gas pipelines with renewable energy. This is an entirely new proposition. One, I'm happy that the gas grid can do this. Two, it has impacts on the downstream applications. But the other thing is, the big issue with the gas this year has been energy security. We need to ramp up the production of renewable energies that are stored through electrolysis in the form of hydrogen, and we need to get that into the hydrogen grid in Germany. How do you see this transition? It's a massive transition, it really is.
It certainly is a massive transition, and certainly there's always the worry of the people that that there's not enough hydrogen because we cannot produce enough hydrogen in Germany. We don't even need to do that. There's enough hydrogen available as excess hydrogen in Europe and in the MENA region, like importing from Africa. And we have done studies that the amount of hydrogen that is available in 2030, in 2045, can cover the amount of hydrogen that is required. And that study was done before our chancellor went out to Canada, to Chile, to Australia to acquire more hydrogen from overseas. So there's certainly enough hydrogen. Certainly it is a big task also for the industry. We are in very close contact with some of the industries. Not all of them yet, but it has to be recognized also for the industries that hydrogen is for a lot of industries, especially when we talk about thermal processes, the easiest way to decarbonize and to follow a net zero strategy with hydrogen. And in a lot of cases even easier and a lot easier than electrification. We are working. For example, just let me give one example. We're working with BMW in Leipzig, and they have changed their intralogistic system. So all the little cars that are running around there and bringing the parts to the assembly stations, all these little cars, they are now running on hydrogen because it's just easier to fuel and it's faster. And we are bringing together all members, which are the infrastructure guys. We are bringing them together with the industry to make sure that the interfaces are right and that they know of each other, what are the requirements, what is the quality of hydrogen they need. And that is, as you say, a big task, but we need to be prepared for it because it's the way to decarbonize.
If anyone has a question at this time, just raise your hand and wave, and I'll try and address it. One question.
Okay, thank you very much. Now, International Energy Agency is running a new campaign, electrification. So, making electricity available for every needs at every point. So, it is kind of conflicting into transporting and distributing hydrogen instead of natural gas to every point where they are needed. versus making electricity available for every need. So electrification versus distribution of the hydrogen to the end user. How will it evolve? What do you think? How do you expect?
I think the word I don't like there is the versus, because the task is so big, decarbonization and defossilization actually it is, because we can also use biomethane. So the task is so big that we need electrification where it is necessary and where it makes sense, and we need to defossilize the molecules, because the task is so big that we cannot electrify everything. It's just not possible. For the amount of energy that we need, for the storage that we need, but also for some applications where for high heating applications it just does not make sense to use electricity. And obviously, yes, it does not make sense to fuel a car with hydrogen when it stands right next to a solar panel. Of course, if I have a solar panel and an electric car, I want to bring the electricity into the car. But if I need to import, and Germany is an import country, I said 3,500 terawatt hours. If I import energy, and that is not possible in large amounts with electrification, then I'm importing molecules, and then it does in a lot of places it does not make sense to convert these molecules to electricity if I can use the molecules directly in heating appliances or in thermal processes.
And it is amazing, isn't it, how you can convert hydrogen to other conventional gases, and surprisingly effectively, ammonia, a pile of other things that can be done. There's a few specialists in the field who talk about efficiencies there, and they're very, very high. It is this conundrum, isn't it? Because Germany in no way can produce enough renewable energies here to fuel this the industrial complex. When we look at the process right now, so there's always this question of, okay, so we have to move quickly. Where do you see the things that are holding us up right now? What are the problems in getting there? We know what we want. What's the problem?
I think we always say that in the meantime, the willingness is there to transform. The technical ability is there to transform. Also, the quality infrastructure is there to transform. So that we have almost finished all the norms and standards and rules. We have a big project, a roadmap where we analyze that now, where the gaps are. But we have gone a long way. The biggest task at the moment and the biggest problem, I would say, is the legal framework. We still have a discussion on unbundling on the TSOs, for example. So. We're willing to do it, we're able to do it, but at the moment, nobody lets us really do it. So that's the biggest task we have at the moment, to have a legal framework, to really then also have a security for the operation, to have a security in the whole system, so people can also start spending money, because nobody will spend money if there's no security.
Well, Björn, this has been a huge learning curve for me. It's the first time I've heard about the capacity of the German gas grid to deal with hydrogen. No one has had accurate information on that, literally no one. This is the first time I've heard people who actually have looked into the issue. So that is a big game changer for all future conversations here. I hope you'll come back next year to add to this conversation. We need the transformation of the German gas infrastructure into a hydrogen infrastructure. We need it desperately, and we need it as soon as possible. Björn Munko, thank you very much. Hope to see you back here next year.
Thank you very much. And thank you.
And thank you.